Hello guys, so welcome back to our course. This is the last lecture on diodes, okay, and we're gonna study in this lecture some special diode types. The first type or the first special diode here is the Zener diode. The Zener diode, you know, is very similar to the normal diode, which the normal diode usually called the rectifying diode. Also, it has relatively, you know, low breakdown, very low breakdown voltage. So we see that the rectifying, diodes has, you know, breakdown voltage in hundreds, like 1000 in the lab, for example. But this guy, no. This guy has a very low breakdown voltage. It's usually, you know, between 3 to 20 volt. Very low. Okay. So as you see here, guys, it's really very similar to rectifying diode. Okay. Also, another, you know, in difference is that the VD-on or the VBI of the Zener might also be less than 0.7. Okay. Also, it's not that big difference. The big difference is really, you know, in the breakdown, and we usually use the Zener just for its low breakdown voltage. Okay. And if this is VBI is not mentioned, you can just consider it just like any silicon diode, and the VD-on is 0.7. Okay. And again, you know, this characteristic here can be approximated using that characteristic, in which again we have a forward region and the reverse region, just like the normal diodes. And in forward it might be off, and it might be on, and in reverse again it might be off, or it might be on. So basically, since we have a current, then you can say it's on. Okay, so that's the on, of course, in breakdown. So whenever the Zener goes into breakdown, then it's on. Okay, this is basically the symbol for the Zener, and it's really nice one because it's very similar to the diode. Also, we have these two extra, you know, bendings. Okay, and this bend, you know, is basically what you have here. So you have this, on region. In forward, and you have this on region in reverse. So just, you know, saying to you, oh, this guy can be on in forward and reverse. Then you have these two here. Okay. Another two, observations, about the operation of the Zener is that it has what's called IZ minimum and IZ maximum. Okay. In the constant voltage model here, I consider that whenever the diode goes into breakdown, it just needs the input voltage to provide it with minus VZ or V breakdown. We usually call V breakdown here VZ. This is basically, okay, the breakdown voltage. Also, practically, you need two stuff. You need V breakdown, you need a voltage, at least V breakdown, and also IZ minimum. So we can say there are two conditions for the Zener to go into breakdown. The voltage must be greater than or equal to V Zener or V breakdown as a magnitude, of course, because this is basically working reverse and it will be minus. And the current as a magnitude again should exceed or at least become IZ minimum. For example, 1 milliampere. So the current must be, you know, at least 1 milliampere, minus 1 milliampere, of course. You know, but usually in our circuits in this course we're gonna ignore IZ minimum. We're gonna consider IZ minimum just 0. I mean, to go into breakdown, we just need a voltage, an input source, we can say, sufficient to provide VZ or V breakdown. Okay, and the transition point here at which we will just start. This is a transition point. Has a current of 0, just like this transition point in forward. Okay. Finally, IZ max, this is the maximum current that can flow in the Zener in breakdown before, the diode breaks. Not breakdown because it was really working in breakdown, but breaking here means burn, for example, just, burn out. It will become open circuit or whatever. Okay, so basically this is relating to the rating. So any diode has what's called rate. Any Zener diode has what's called rating. So the maximum rating or maximum power basically that the diode can withstand without breaking or without burning down is VZ multiplied by or times IZ max. Because at that point the voltage is VZ. Okay. And of course the power should be positive. So we say VZ positive multiplied by IZ maximum. Okay. Again, we will not just touch on that a lot. You know, in our course, usually we use, you know, the constant voltage model. We ignore IZ max, and we assume always that IZ max is, you know, infinity, and IZ minimum is just 0. Okay. But of course, these are practical considerations that you should take care when you implement a circuit using a Zener diode. Good. Now, let's, you know, solve some example and see how can we deal with the Zener, you know, in a circuit. And you will find out that, you know, when we do it with a Zener, it is exactly like dealing with diodes. Exactly like dealing with diodes. Okay. So in that circuit in here, we have two resistors, R1 and R2. R1 is 20 kilo ohms, and R2 is 5 kilo ohms. Okay. And we have a diode here connected in that direction. It's a Zener diode. And V Zener is 10. And look here, the V Zener is 10 is positive, but we know, you know, it is a standard. You know, in all boxes that you can read, you will find that always we mention that V Zener is positive whatever, positive 1, positive 2, positive 3, 5, 10, 20. Okay, but we know this is a breakdown voltage, and when we go into breakdown, the voltage of the diode will be in that direction and it will be negative. Okay. So find VD and ID, and here is ID. Okay, and the directions are really important in here. When the input here is 20, 35, and minus 2. Minus 2 will be your homework. We're going to do 20 and 35 only. Okay? Good. So let's start here by 20 volts. So the input equal to 20 volt. Okay. I'm going to assume here a current called I1 and a current here called I2. Okay, I'm going to assume that this point, let's call it, it's basically, how much? Let's call it 1, V1 for example, whatever. Okay, so let's calculate I1. Before that, so let's check first, you know. So let's check now. So let's check now, you know, if the diode is forward or reverse. Okay. So if we look, this is N closer to the positive. This is B closer to the negative. Or you can say that this battery will push a positive current in that direction. This positive current will come at that node and branch it like this. So basically, this should be a positive current flowing in this diode from N to B. So it's also, you know, reverse. So the diode is reverse. Good. In reverse, we might be here or here. Means a breakdown or just off. And if we are breakdown, this is on, by the way. Okay, but the current will be negative and the voltage will also be negative. Let's look at the input. The input is 20 volt. Also, V Zener is just 10. Okay, so looks like we don't know. Looks like this is a sufficient voltage, input voltage, to turn this diode into breakdown. Okay, so let's assume the diode is breakdown as well. How we can verify if our assumption is correct or wrong? Basically, we will calculate ID. If ID is negative, we are right. Because look, if you are negative, the voltage is minus VZ and the current should be negative. Otherwise, you will be here in the off region and the current will be just 0. So let's do that. If the D is in breakdown, so VD or, you know, VD, yeah, is minus VZ or minus 10. It's in breakdown. Good. Let's call this current I1 flowing in R1 and I2 flowing in I2. Okay. Two current, just name them whatever you want. So let's calculate I1. I1 is basically this point minus this point over R1. Let's call this point here in the middle V1. So this should be equal to V input minus V1 over R1. V input is 20. Remember, this is the ground. Okay, so that's why this point is just V input. Minus V1. Let's now check V1. How much is V1? So since the diode is in breakdown, so the voltage in here in that direction is minus 10. So that means this point, which is the ground, is greater than this point, which is V1 by minus 10. Or 0 minus V1 equal to minus 10. So basically V1 is 10. So let's go back to I1 equation here. So 20 minus 10 minus V1, which is 10, over R1, which is 20. So this is basically 10 over 20. It is 0.5 milliampere. And it keeps the resistance in kilo ohms, so the current will be in milliamperes all the time. Now let's calculate I2. I2 is flowing in the resistor R2 in that direction. So it's equal to that point, which is V1 minus 0 over R2. V1 minus 0 over R2. V1 is how much? V1 is 10 minus 0 over R2, which is 5. So this is basically 2 milliamperes. Now is the moment of truth. Okay, if we are so ID is in that direction. Remember, this is ID. Okay. So at that point at V1, so KCL at node V1 will give you what? I1 is going into the node. ID is also going into the node. I2 is going out of the node. So this is basically equal to I2. So from that, ID equal to I2 minus I1. I2 is 2 milliamperes and the I1 is half milliampere. This is positive 1.5 milli. This is basically wrong. Wrong. Because since we assume that the diode will break down, its current must be negative. And what we have here is a positive current. This is incorrect. If we are in breakdown, the current must be, negative. And that since we have inconsistency here, okay, that means that the assumption was incorrect. So the breakdown assumption basically is incorrect. Remember, the diode is reverse. There is no doubt. It's not assumption, So it's a reverse, but not in breakdown, not on. So it must be off. So the diode must be off. It's off. So it should be here. How can we verify that? Again, if you are really off, the current is 0, and the voltage must be something between 0 and the minus VZ or minus 10. Like, for example, minus 5 or minus 6, something between 0 and minus 10. Okay, that will be our verification now. So, since the current is 0, okay, because the diode is off. Okay, let's calculate VD. Okay. If the current is 0, then basically, I1 will be equal to I2. Okay. And how much? Then basically R1 and R2 are in series now. So I1 will be equal to I2 equal to V input, divided by the total resistance. V input over R1 plus R2. V input is 20. And R1 plus R2 is basically 25 kilo ohms. So this is basically, keep it like this. Keep it just 20 over, 25. This will be milliampere. Keep it like this, that's fine. Okay. Now the moment of truth, because we should now calculate, you know, V Zener, or I'm sorry, V diode, and it should be between 0 and the minus. It will be like this, because we know that if it's not off, if it's not breakdown, it must be off. But just to, you know, to check on yourself. So let's do that. We know that VD, if we make a Kirchhoff in here, so, or make it in the other way. The voltage of R2, let's call it VO. Okay. So VO plus VD is equal to 0. So from Kirchhoff, VO plus VD equal to 0. So basically here, VD is equal to minus VO. And VO is basically the voltage of the resistor, R2. And R2 is equal to I1 or I2 because they are equal now, multiplied by R2. This is basically I1 R2 or I2 R2 equal to 20 over 25 milliamperes multiplied by R2. And R2 is 5 kilo ohms. It is 5 kilo ohms. So this is basically, you know, would be 5. So 4, you know, volt. So VD equal to minus 4. And as absolute value, this is less than, you know, VZ, which is 10. Okay, so basically we are something like here. For example, minus 4. It's far away from the breakdown. Okay, also here the input is, you know, greater than the breakdown voltage, but we still not in breakdown. Okay, and here is, you know, another way to deal with such a circuit and to get it right from without making any assumption. So now we finish the solution. We solve it number 1. Okay, but I'm gonna show you now another way to solve this problem. Okay, which is basically, you know, by determining, like what we did before, the minimum input, okay, that will make the diode to go into breakdown. Okay, the minimum voltage required for the input to make this diode to go into breakdown with whatever the input is, you know. Then whatever the input is, you just compare this input to this V input minimum, we can say it like this, and, you know, you will know if this will be enough for the diode to go into breakdown or not. Okay, so just make it with red, for example. Calculate. So that's it. The assumption is correct. So V input minimum, that will turn the diode on in breakdown or in reverse, whatever. Okay. At that point, V input equal to V input minimum, VD is minus VZ, and the ID is equal to 0. Basically, we're gonna work on that point, the transition point here. Okay. Can we determine, you know, V input minimum? Yes, we can determine it. Okay. So look here at the circuit. Okay. Now ID is equal to 0, and the voltage here is minus 10. So we know now the output, right? So the output at that case is equal to also to minus 10. Okay. So the current I2, which is flowing in that direction here, equal to what? So no, yeah, because V output is equal to minus V, so VO will be equal to 10, not minus 10. Okay, so basically based on that, we can say that I2 is equal to 10 over 5, which is 2 milliamperes. So in that case here, VO will be equal to minus VD, so it will be equal to positive 10. So I2 will be equal to 10 over R2, 10 over 5 kilo ohms, 2 milliamperes. And this is equal to I1, because again, we are on the transition point, so ID is still 0. So this will be equal to I1 because ID basically equal to 0 on the transition point. Now from Kirchhoff, the input minimum equal to I1 R1 plus I2 R2 or plus VO. Okay, so I1 R1 is 2 and this is 20. So this is basically plus I2 R2, which is basically 10. So this is 40 plus 10 equal to 50 volt. So we need the input to be 50 volt at least, so that the diode can turn, on in reverse or go into breakdown. You call it whatever, on or breakdown, whatever. Okay. Now, in a very simple way, we can say that in 2. So we can now solve the input number 2 in a very easy way. So let's do that with another color, green, for example. So for 2 now, since the input equal to 35 is less than 50, the input minimum, then the diode is off. And since the diode is off, so ID will be equal to 0, one of the unknowns. And you can determine, ID, VD in the same way. So again, I1 will be equal to I2 equal to the input, which is 35 over R1 plus R2, 25. So VD will be equal to minus VO equal to minus, and VO is I1 or I2, 35 over 25 multiplied by 5. So this will be basically 7 minus 7 volt. Minus, again, this is again less than V breakdown or V Zener. So that proves to us that we are still minus 7 in here, still far from the, or didn't reach, the breakdown. And that matched what we assumed in the beginning. We assumed that, okay, since the input is 35 less than 50, so it's off. It's not breakdown yet. And that's what we get. We can verify with this. If you find that the input, the VD is 10 or minus 10, of course, or minus 11 or something, then you have something incorrect, inconsistent again. Okay, guys. So that's basically, how to deal with circuits with a Zener. And again, this is your homework. The input is equal to minus 2. To make it, easy for you, when you put the input equal to minus 2, you're gonna flip the battery. Then the Zener will be forward. Then you deal with it. Just replace it with just a normal diode. It will be exactly the same. Again, the diode needs the 0.7 to turn on. So you might need to determine now another V input minimum. The input minimum now, not that one that we just calculated, which is 50. No, the input minimum that is enough for the diode to turn it on in forward bias. Okay. Let's call them V input 1, V input minimum reverse, and V input minimum forward. What we calculated here, this guy here, this one here, this is V input minimum in reverse. You need another one for forward. Calculate it, then compare this to with it. If it's greater, then yeah, it will turn the diode on. If it's smaller, then it will not turn it on. Okay, guys, thank you very much for watching this video and see you in the next video. Bye-bye.